Hi, welcome back. This is Learn How to Program, and I am your instructor, John. Today we are going to talk about for loops and lists. This is part 4 of our course. So first, I wanted to give you guys an overview of the course so far. We've gone over what is programming in the intro. We have gone over variables, what they are, how to store them, how to use them in part 1. In part 2, we talked about ifs, booleans, and control flow, where we learned how to tell our program where to go by means of if and else statements and by using control flow. In the third part, we talked about functions, what functions are, how to create functions, and we went through a bunch of fun examples of functions and what you can do with them and why they are actually so powerful. In this part, in part 4, we are going to talk about for loops and lists and their role in programming. So what actually is a list? Well, a list is a grouping of elements that share the same data type. As always, here's an example to the rescue. So we're going to talk again about Samantha. Samantha is a fictional character that I actually made up. Samantha wants to invite 5 of her friends over for her 8th birthday party. So here is the list of all of her friends. She decides to invite Timmy, Tommy, Tammy, Tamara, and Bob. As you can see, we have a wide range of ages from 6 to 8. Well, actually, I guess that's not that wide, but whatever. So Samantha's pretty smart, and Samantha would like to make a list of all of their ages and find out what the average is. I'm not exactly sure if that's part of the curriculum of a 2nd grader, but who cares? Here's a list of all the ages of all the kids. So we have 2 7-year-olds, 2 8-year-olds, and the youngest is a 6-year-old. So as you can see, we have a pretty wide variety here. We have 8 twice, 7 twice, and 6 once. So in a list, in a programming list, you can also have repetition. So as always, show me the code. Well, here we have a variable. The variable's name is ages. What ages holds is a list of, or a list, and inside you can see a bunch of elements of that list. So all of those numbers that we just talked about a second ago. So the first part about this that I wanted to highlight was the list declaration. That's this list of part. You can also leave the stuff in the middle of those parentheses. You can leave that blank, and then you would just be declaring an empty list. But in this case, we actually have elements in our list, and they are called list elements. So here we go. Again, you declare a list by saying list of, then you open parentheses, you put your elements in there, then you close your parentheses, and you are done. So now what do we actually do with this? Well, now that we've actually created this variable, we need to compute the average. So once again, we are going to use some math. So here we have a function that I've declared called compute average. The next part about this that I want to highlight is the ages variable that we just went through a second ago. So we declare this variable val ages equals, and then list of, and then all of the items in our list. 7, 8, 6, 7, and 8. The next thing that we do is we take this ages variable, and then what we do is we call the average function. This is available to any list of type int. If you take a look at what we declared above, everything in there is an integer. 7, 8, 6, 7, 8. All of that is an integer. And when that is the case, when you put that into a list, you have access to this function called average, which will compute the average for you. So you don't need to write this function by yourself. It's really cool, super nifty. There's a lot of stuff like that in the Kotlin language that just makes your life easier. The next thing that we do is we assign the result of this average, so ages.average, to the average age variable. Then what we do is we print it out. And when we print it out, what you actually see is the result of 7.2. Great job. Now we know the average age of all of these kids at the birthday party. But you can really do so much more with lists, and there are 3 things with lists that I would love to highlight and point out to you that we are going to go through today. So the first thing that we're going to do is we are going to find items by using filter. How filter works is it gets a list, you give it certain criteria, and then you filter for that criteria. So for example, let's say that you wanted to get all of the kids whose age is greater than 5, then what you would get back is a list that matches that criteria. And then, for example, if the list contained a kid whose age was 4, it wouldn't be included in the new list. But don't worry, we are going to go through all of that very shortly. The second thing that I want to go through is transforming items by using map. So let's go back to our example with the ages. Let's say that you have a list of ages. If you were to map them, what it actually means is that you're going to transform them. So for example, you would take everybody's age and you could multiply it by 3. So if the kid's age was 6, then you would multiply it by 3, boom, then you have 18. And you do that for each and every element in the list. The last thing that I want to talk about is something that programmers use a lot. It's called the foreach in Kotlin, also known as a for loop. But basically, you could loop through items in a list and then you could print out their names, for example. So let's go through what finding something with filter actually looks like. When I highlight something with the teal-ish color, then you know that we are actively doing something with it. So what we're going to do is we're going to look for the guests whose name starts with a B. As you can see, Timmy, Tommy, Tammy, and Tamara, all of their names start with a T. So going through all of those guys, we reach the bottom and then we hit Bob. Bob's name starts with a B. So we move him out right there. That's what the teal color is for. And that's why I moved him to the side. And then what we get back is a new list, like I said earlier, with just Bob in it. That's what filter does. You give it an input list, you filter with some criteria, and then you get back a new list. Here's another example for lists that I also like. So here we have guests with names longer than 3 letters. As you can see, Timmy is a candidate. So is Tommy. So is Tammy. So is Tamara. And then poor Bob is left out. So what we get back is a new list only with Timmy, Tommy, Tammy, and Tamara. Bob is gone. There you go. Here's our new list. We had a old list that included Bob. Then we looked for things. We filtered for things where the number of letters in the name was greater than 3. And then we were only left with these 4 guests. The next thing that I want to talk about is transforming the items by multiplying them by 3. So let's go through each of these people individually, each of these kids individually. Let's start with Timmy. Timmy, we multiply his age by 3, we get 21. Then Tommy, we now get 24. And then Tammy, her age was 6, now it's 18. And then we keep going. And then what you get is a list like this, where all of the ages have been multiplied by 3. As you can see, we've actually not filtered anything out. We've just taken every single item in the list and then done something to it to transform it to something else. The next thing that I want to highlight is displaying the items with a for loop. So what this does is we take Timmy, and then instead of returning Timmy, instead of mapping Timmy, so transforming him, we just take him and then we print him out, like in this format that I highlighted below. Obviously, you can print it out in any format that you want, but I chose to do it this way, where you have the age and the name, then you display it as 7-year-old Timmy. And then if you keep going, you would also have 8-year-old Tommy, and then so on and so forth. And then, for example, in this for each, in this for loop, you could tell it, hey, if the name is Bob, print out and Bob, for example, just to be funny. So let's just quickly summarize what we just did. We found things by using filter, where we gave it a list and then we got back a new list matching our criteria. We transformed things using map, where we went through each item of the list and then we did something to it, like multiplying the age by 3. And then we displayed something, which is neither finding something nor mapping it. We just took each item in the list and then we displayed it. So now I'd actually like to go through some exercises together with you guys. So the first exercise will be a filtering exercise where we will find stuff using filtering. The second, we will use map to transform stuff in a list. And the third, we will use for each to display things from a list. So the link is in the video notes. It's under blank exercises. Alternatively, you can just type it in like this, but I actually think that's a big pain in the butt. So just pause this video, go to the video notes, click on the link, and I will see you in the exercises. Welcome to the exercise portion of our class. So right now, what we are going to do is we are going to filter a list, we are going to map a list, and then we are going to use for each on a list. So for the very first exercise, we will be doing some filtering. So the point of this exercise right now is that let's pretend like we work for a company and they are trying to make a new superhero. You, as the programmer for the company, are trying to convince them that they should probably avoid using the word man for a superhero, and they should instead come up with something original. So the goal is you have a list of superheroes, and then you want to find all of the superheroes that contain man in them, and then return that list. So what we are actually going to do is we are actually going to filter. We are going to find the ones that contain man and then return them. All right, let's get cracking. So let's scroll down here, and here is our method stub. So we have some characters, okay? And with our characters, we want to perform a filter. So this syntax is going to be new to you. So you say filter, then a space, then you open and you close brackets. So all of the magic is actually going to happen in here. And it can be this long, it can be that long. It doesn't really matter. What matters is the stuff inside of here. The next thing that you do is you need to actually touch each individual item. So how this works is you type in IT, space, and then hyphen, and then greater than, and then here you go. So this looks like, you know, a little bit alien, but let's just take a look at this. So what this actually means is item. So for each item in my list, I want you to filter it with certain criteria. And so now you need to actually give it the criteria. You do IT and then dot contains and then man. So the first part right here is just saying, okay, this is what I am going to call each item as it comes in. We could also call this like just like a variable. We call this like Batman, and then call this Batman. Or we could call this, let's just call this variable. That's a better example, actually. And we'll also call this variable. So what this says is actually for each character that comes in, okay, so that would be, for example, for Mario, Superman, Spider-Man. For each variable that comes in, I want you to check and see if that variable contains man. If that is true, it will actually be returned in the new list. So you might be wondering, why aren't we doing this a bunch of different times? Why are we only doing this one time? Well, actually, that's kind of the magic of all of this. You apply this filter for this variable, and it applies it to all of the stuff in that list. So actually what we should be doing is just because that's the regular convention. Okay, so just remember, this filter takes in this criteria right here for each item. And then what we have to do is we have to store the results somewhere. So let's do val, and then let's say result. That's the name of our variable. Okay, so what this is going to do is it's going to return a new list where everything in the list actually contains man. So let me prove to you that this actually works. Let me just return this right here. And then maybe we can go through this again just so that you understand how this actually works. All right, excellent. Take a look at that. So let's go back up here. Here we actually call the method, and then we throw in the characters. All right, and then we print the return. What it actually returned was these guys right here. And as you can see, each of these contains man in there. Very interesting. So that applied to every single item in this list. This is a very important point. This filter applies to every single one of these items. And if you get that, then you're pretty much, already mastered looping. That's a really important thing to talk about. So if we were to say, for example, contains, let's see something that only is found in one of these. Let's just say Eve. Okay, so let's just change this right here and let's just say Eve. So actually it's going to check, okay, I'm going to filter this list for this item in the list. Does this item contain Eve? Mario, no. Superman, no, 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 no. Yes. No. So it's going to return a list where the only item is, yes, you guessed it, Steve. So let's just prove that that actually works. So let's hit play. Boom, look at that. Steve is the only item in that list now. So let's go back to man. And again, it's going to go through every single item, check if man is in there, and then if it is, it returns it. Excellent. Now the next thing I did is, so this is the, wrong exercise. All right, so this is the superheroes with man. Then what I did is I called a method .size. This is available to any list, and it will tell you how many elements are in the list. So 1, 2, 3, 4, 5. And that is the 5 that we see right here. Really good job, guys. So now moving on to exercise 2. This is going to be a mapping exercise. So what we have is a bunch of missions. These are actually Apollo lunar landing missions, and these are the years in which those missions actually occurred. So 68, 69, 69, 69, blah, blah, blah. So your mission is to, let's just say that the missions happened actually 10 years past what was actually like said. So let's pretend that 1968 wasn't actually the mission year, but it was 1978, 1979, 1979. This would be 1980. This would be 1981, blah, blah, blah. You get the picture. So let's just advance this by 10 years. So let's go down here and let's take a look at this. So we have a list of missions, which is the years, and we want to get a list of also of years back. So what we need to do is we need to transform this. We need to add 10 years to each item in this list. So how do we do that? Okay, first let's grab missions. Well, actually, how would we do that just normally? So let's just take val and let's take a number. And the number is, I don't know, 1600. So to add 10 to that, we just take, let's just print it out, number, and then just add 10. So that's actually all that you really need to do for a single item. Okay, and now we need to transform this and put this actually into a loop so that it affects every single item. And that's what mapping is all about. So let's just take our missions, and then just like the filtering, let's call map. Okay, so same syntax as before. You have the it, like that, and then you take your it, and instead of doing a contains on this, all you're going to do is just add 10 to it. And that's really it. So instead of doing this for one item right here, you are looping through all of the items. Okay, so you're looping through 1968, 69, 70, I can't think of the other years right now, 72, blah, 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 and you're just adding 10 to it. And when you get back from this map is a new map, or a new list, sorry. So you get back advanced years. Excellent. So let's get rid of this right here. So now we have our variable, and don't forget that we have to actually return this variable. And let's just return advanced years. That's exactly what we wanted to do. Okay, so let's go through this one more time. You have your missions, and then you map each item. You transform each and every item. You take the item, and then you do something to it. In this case, we just add 10 to it. And now when we click on play, look at that. That is exactly what we wanted to see. Each and every item has been advanced by 10 years. In the following line, I did something kind of interesting that I wanted to show you guys. I just wanted to highlight this. So you have the mission years. These were returned by this function, right? So we called this function, we gave it the missions, and then it gave us back this dude right here. In the next line, what I did is I called distinct, and this is available on anything of type list. And what it does is it actually returns a new list and it eliminates all the duplicates. So that's why in this one right here, you have 78, 79, 80, 81, 82, so on and so forth. I just wanted to show you guys that there are some cool things built into the language that you can use just in case you wanted to, for example, get unique years. So moving on to the next exercise. Okay, so attention. We are actually going to introduce something new. It's called a pair. A pair can hold two things of any two types. So it could hold a string and a string, a date and an int and a date, a string and a boolean. This is very convenient, and it allows us to save more info with less work. So up until now, we had, for example, a list just with math, physics, dance, theater, and history, or a list just with numbers. So 84, 78, 90, 91, 99. That's all cool and fine and well, but actually what you can do is you can combine two things together in Kotlin. So let's just do guest. Okay, so you create a guest by creating a pair right here. Okay, and now this first item right here can be any type that I want, and this second one can be any type that I want, and they're combined inside of this pair. So for example, my guest name is John, and then let's say my age is 108, because I'm not going to tell you my real age. Okay, cool. And so now if I do print, please cooperate. If I do print line and then guess on here, let's just print this out. And then let's see if we can find it. All right, here's John, 108. So this is two pieces of information put into a single pair. That's all that is. Two pieces of info that are put together into a single variable. All right. And I could have done something like, I don't know, 23 in here, or yeah, let's just try that. And then what you're going to see is a single variable with two values, 23 and 108. And what's cool about this is you can also do guess.first, and that will return just 23. So let me just show you that that's true. 23. Or guess.second, and it will give me the second part of this variable. So this is just very important to know. We are going to use pairs a lot going forward, and I wanted you guys to be aware of this this kind of new way of storing information in Kotlin that I'm a huge fan of. So now when you see these grades, it doesn't look as weird. What you have is a pair. So this is a list of pairs where each pair contains the class and then the grade that you got in that class. So the class, grade, class, grade. And each one of those is in a pair. And each of these pairs is in a list. So if you got confused, please pause the video, rewatch it. I think it'll make more sense the second time around. So for this exercise, what we actually need to do is we want to print out these grades in a nice fashion. We want to use this format right here. Okay, because you want to impress your parents with your grades. You can read this on your own time right here. And you want to print it out in this pretty format right here. So in order to do this, instead of using a map or a filter, we're going to use a foreach. So we already know how to print something. Okay, so that's kind of the first step. If you can do it for one thing, then you can do it for all things. So what I mean by that is if you can print one single thing. So for example, I am tall. Now let's try and plane that. All right, great. Here is I am tall. But now we need to do this in a loop. Okay, so a loop. That doesn't sound like that big of a deal. We've done that with filtering. We've done that with mapping. But in this case, we don't want to filter and we don't want to map. Okay, so we take our grades. Then what we do is we do a for each. Now, just like with mapping and just like with filter, we do it, which is the item. And then we do this arrow syntax right here. And then now right here, we're not going to do it contains. We're not going to add 10 to it. We're just going to print. So let's just print out I am tall just to begin with so that you can get a hang of this and what this actually means. So what we're doing is for each of these grades, we are going to print out I am tall. So let's go up here for each of, where are the grades? Oh, here we go. So for each of these guys, we're going to print out I am tall, which is kind of nonsensical, but whatever, it gets my point across. All right, as you can see, I am tall is printed out. So we have 1, 2, 3, 4, 5. We have 5 plus that extra that we left behind right here. That's why there were 6. Okay, great. But we still haven't actually printed out what we wanted to print out. We want, so the goal is this format right here. And right now we are printing out I am tall. So why not just swap it with it? You guessed it. There you go. Let's just play And then what we should see is, oh, look at that. Math, physics, dance, theater, history, and then all of the grades. Really good job. But this still isn't quite what we wanted to do. What we wanted to do is let's grab this right here. If you remember from past videos, we use the templating stuff in Kotlin. It's really cool. It allows you to inject variables into strings. So this is looking for a variable, but obviously we haven't created one here. So it's going to fail, and it's looking for this variable. So what we're going to do is we take this it, and we are going to extract stuff from it. So if you remember, we can do, for example, it.second, and then this will give us back the actual grade, right? Which still doesn't help us right now, but I just wanted to show you guys how you can decompose these things. So instead of printing this out, let's save it to a variable. Well, actually, let's do this. Let's do val and then name of class, just to satisfy this guy right here, okay? And now it, and we want the name of the class, which as we know is first, okay? It's this guy right here. So this guy is now green. Excellent. So let's get the second guy green. Let's do val, and then you guessed it, grade in class. Awesome. And then it dot, yes, you guessed it, second. So now both of these guys are satisfied. And this is exactly the string that we wanted to print out. So let's just try it. Well, look at that. In math, I got 84. In physics, I got 78. In dance, I got 90. Yada, yada, yada. Fantastic job. This was a lot. All of these exercises were a lot. I'm very proud of you. We went through filtering. We found all of the superheroes that had man in them. We did mapping. What we did is we took the lunar landing missions, the year in which they occurred, and we added 10 years to them. And then the last one that we did right now is we took these grades and we printed them out in a fashion that would make our parents very proud. All right, I am looking forward to seeing you guys in the summary. So first of all, really good job with those exercises. That was not easy. Now we are going to summarize what we have gone through so far in this lesson. So a list, what is a list? A list is a grouping of elements that share the same data type. So there are three main applications of lists that we went through today. So we found stuff by using filtering, like we found superheroes that contained man in them. We transformed stuff using map, like all of those lunar mission years. We took all of them and then we pretended like they happened actually 10 years in the future. So we took a year and then we added 10 to it. We mapped it and then we returned an entirely new list with all of those advanced years. And then finally we displayed stuff using foreach. We had a bunch of grades and then we wanted to display them in a very cool way to show off to our parents. Okay, so this is a very important part of this entire course. You need to be doing the homework in order for this stuff to really stick in your head. So what I need you to do is to go to the link right here that's provided. You can go to the video description and then underneath blank homework, just click on the link, or alternatively, you can just type it in right here. But what you should be doing is attempting this homework by yourself. And then when you get stuck or when you've finished, come back here and we will tackle this together. All right, see you soon. Welcome to the homework section. So in this section, we are actually going to be doing the exact same thing we did in the exercise section of this video. What I mean by that is we are going to be doing some filtering, we are going to be doing some mapping, and we are going to be doing some displaying. So in this first exercise right here, the point of this is we have a bunch of sources of income for Uncle Bob. As you can see, you have Apple stock, gold, silver, Ethereum, eBay stock, and vintage Lego sets. And so what we want to do, or what Bob wants us to do, is we want to return a list where everything in the list has made more than $500 in this year. So what this means actually is that, you know, the Apple stock made this much last year, gold made this much, silver made this much, Ethereum made this much, yada, 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 yada. So you have your list, you filter it for everything above 500, so it made more than 500 in a year, and then you return it. All right, let's see if when we click play. All right, excellent. This is exactly what we wanted to see because so far we just have these method stubs. So we have our list right here. And if you remember from the exercises, we take the incoming list, Bob's income sources, okay? And then, well, we can either return it directly or put it into a variable. So I'm going to put it into a variable. So let's just do top performing income, like that. Okay, so now we need some space in order to write our function. So we go through it with filter, and we want to look for very specific criteria. You might have noticed up here that these are actually pairs. We went through what pairs are in the exercises. If you're not sure, please go back to the exercises and then come back to this section of the video. So these pairs are composed of a string and then a number. So what we want to do, if I can find myself again, all right, excellent, is we want to filter by the income that made over $500 in a year. So, like in the exercises, we do IT and then space and then the arrow thing right here. And now we want to take a look at, remember that this is a pair. So a pair has a first part to it and a second part to it. And the first part to the pair right here is the Apple stock, and the second part is the money. What we are interested in is the money. So we go down here and we want the second portion. That's exactly what we wanted to do. Okay, but now we need certain criteria. So filter where the second portion of the pair, so the second portion of this income pair is what? More than 500. That's the only thing that you actually need to do. Really cool. The problem here, though, is that this is still not going to work because we have to actually return this. So let's return the top performing income. Okay, great. So one more time going through this. Okay, great. We have a function right here where we have filtered all of the income. We took a look at the second part of this pair, right? And then we checked to see if the second part was above 500. So this goes through each of these sources of income. This guy, this guy, this guy, this guy, this guy, and this guy looks at the second part of each one and determines if it made more than 500. If it did, it will be returned in the list. So now let's just verify that that actually worked as intended. All right, take a look at that. Apple stock made this much, silver made this much, Ethereum made this much, eBay made this much. Yes, all of them made more than 500. Really nice job. All right, let's move on now to the second problem. So in the second problem, I'm just going to read this for you because I wrote it and I thought it was pretty funny. So Einstein is a physics professor, but always seems to have issues programming. He needs you, his lab assistant, because he wants to make his problem sets funnier. For every problem in his list, he wants you to replace the word Earth with donut. This guy. For example, how long does it take to orbit the Earth should be replaced with how long does it take to orbit the donut. Since you are a good lab assistant, you don't tell Einstein that this is a bad idea. Plus, you really need the money. So the return type here should be a list of strings, and the input will be a list of strings. So this is a mapping problem, like I said right here. So we are going to have a list of strings. We are going to do something to them. We are going to transform them somehow, and then we are going to return another list of strings. So how do we do this? Okay, interesting. Well, if you remember, what I talked about in the exercises problem sets from a few minutes ago, it's always good to start off with just doing one thing. So let's just do one thing. Let's just see if we can accomplish this, but just for one string. So let's take this string right here. Okay. Let's do val, and then let's do example, because I'm not very clever right now. And let's fix this. Okay, cool. So how would we replace Earth with orbit? Well, we've done this many times before. You just do example, then replace, then we take Earth, right, and orbits. So we've done this many times before in other videos. The only difference is instead of doing it for one variable, we are now going to do it for a bunch of variables. So first of all, let's just make sure that this actually works. This does what we want it to do. So you should always be doing stuff like this where you're not quite sure how to go about it, but you take a really small piece of the puzzle and then you try and make that work. And then you build the rest of the puzzle, the rest of the solution based off of that piece of the puzzle. So what I mean is right now this is going to do the replace. So how long does it take to orbit the orbit? Well, I put in the wrong word. So let's change this with donut and then play. And then, all right, how long does it take to orbit the donut? So now what I meant earlier is this is one piece of the puzzle. We have done this for one string, but now we need to loop through it using a map and do it for all the strings. Okay, so let's do that. We have the Einstein problems. Okay, great. And we want to map. So let's go back up here and let's take a look at these problems. So you see what would happen if two Earths collided into each other. This would be replaced by donut. Why is the Earth round will be why is the donut round? If one Earth gets eaten and nobody saw it, did it really happen? If one donut gets eaten and nobody saw it, did it really happen? So that's what you expect to get in return. And if it doesn't have the word Earth in it, then nothing's going to happen to it. So this guy right here, when it gets returned, it shouldn't be changed at all. So let's go through mapping now. So now, instead of doing this for one string, like we did above, we're going to do it for all of them. So let's go back to our handy dandy syntax. So it's, and then arrow function, that's what this means, arrow function. And then it, and now we need to do the replace here, okay? So instead of replacing it for this example, we need to replace it for this item right here. So it's, and then replace, and then let's just copy and paste because that reduces the chance that I make another stupid mistake. And let's just get rid of this part right here. And then actually we need to save this in a variable first. So let's do transformed problems. Excellent. And now let's actually return this puppy. So transformed problems, excellent. And now let's click on play. Great. Now let's take a look at these problems. What would happen if two donuts collided into each other? Why is the donut round? If one donut gets eaten and nobody saw it, did it really happen? We did exactly what we wanted to do. Very cool, very nice job. But now we actually have one more problem to tackle. So let's take a look at exercise 3. So in exercise 3, what we have is marathon race times. So here is a bunch of friends, and they all did a marathon together. And these are the names of the friends with their time in minutes. So Judy ran it in 199 minutes, Bob in 200, Sally in 145, Sean in 140, and then Marvin in 500. Okay, so this once again is a pair with a string and an int. And this is a list of pairs. All right, so now what we want to do is let's go to the exercise description. Yeah, you just completed your first marathon. Congratulations. You and your friends all finished. And since you're all learning to program together, you wanted to come up with a cool way to share your times. So you decided to create a function that prints the name of each racer and their time. Use this format, okay? So the return type should be nothing. Right? Because we're not filtering and we're not transforming, we're just printing. The input will be a list of pairs. And the bonus, okay, the bonus says try to figure out if you can print out the time in hours, not in minutes. I meant to say can. That's embarrassing, but whatever. All right, so now, like I said before, let's see if we can do this for one of these racers. So, let's take one of these racers up here. And like I said earlier, if you can do it one time, then you can do it in a loop. So let's take this racer right here. And now we have a pair, okay? And now let's print it out in the way that we wanted to print it out. So let's go up here, take this puppy, put it in here, okay? As you can see, we need to build this guy and we need to build this guy. All right, so we can do that by extracting it from the racer. So let's do name of racer. Okay, excellent. And now racer dot, remember this is a pair, so we just want to select the first part. So the first part of the racer is Judy, right? That's the name. And then that gets injected into this print line. Okay, and now the next part is the finishing time. So let's do finishing time right here. And that's the second part of this racer. And that is in minutes. All right, so now we've actually done it for one racer. This doesn't actually solve the problem, but what we did is we did it for one racer, and now we're going to put that into a loop so that it affects all of the racers. So let's run this just to make sure that everything's okay. Let's scroll to the bottom. Judy finished in 199. Judy finished in 199. That's exactly what we wanted to do. But now we need to use a for each loop to display this. So how do we do that? Well, we grab the racers and times, you guessed it. Then we do a for each on them, and then we open up the braces, okay? The next thing we want to do is the it, which we've done over and over and over. And now we need to print something out. So if I were to just print out something like Booga right here and click play, it's going to print that out. How many racers do we have? It's going to print that out 1, 2, 3, 4, 5 times, which is nonsensical, I know. But I just wanted to show you that you have a list, you do a for each, and I don't necessarily have to print out something that has to do with the data in here. I could print out something totally weird and bizarre like Booga. But what I wanted to do was to grab this guy right here and put it in here. But as you know, this is not going to work because in here, in this block right here, we have actually not declared these variables. So this is actually not going to work until we do this in here, until we do this stuff outside of the loop, inside of the loop. So let's take these guys and let's copy and paste them here. Okay. This is super ugly. Sorry about that, guys. Okay. Great. But the thing is, the name of our variable is no longer racer, which refers to this. It's actually it. So all you have to do is replace this with it. Okay, great. And now let's get rid of all of this garbage right here. So now, in theory, this should work as long as we don't have some sort of a bug. Let's click play. Scroll on down, look at that. All of the times are right here. There was a little bonus part to this, and it said, what did it say? Try to figure out if you can print the time in hours, not minutes. Okay, so to do that, let's just go to the finishing time, which is in minutes as we know, and let's actually just divide that by 60. And that should actually give us the hours that it took. Scroll down, and cool. Judy finished in 3, Bob finished in 3, Sally finished in 2, Sean finished in 2. Really good, really nice job. I know that wasn't super easy, and I hope that you guys had fun trying to tackle these problems. All right, I will see you back in the video. So before we split, what I wanted to say is if you've made it this far, that's amazing. This stuff is hard, it can be complicated, and I'm so proud of you for sticking with it and making it to this point. Do not get discouraged. You can totally do this. If you need any help, please write something in the comments and I will get back to you as soon as I can. All right, guys, I will see you in the next video. Bye.